Bo ciekawe, czy nie dodaje rozmowy do wyzwu.
No dobra.
Myśmy z tym miótkiem gramy.
Hello, everyone. Welcome to the first of 8 sessions of today's Ontotext demo day. I'm going to show you the new features, well, some of the new features because there are too many to fit into half an hour that are coming to be released with GraphDB 10 at the beginning of next month. So let's start. The first difference that you're going to notice when you download GraphDB 10, if you've used GraphDB before, is that GraphDB 10 is a single distribution for all GraphDB editions. So up to GraphDB 9, there were 3 different downloads depending on the edition that you want to use, namely GraphDB Free, GraphDB Standard, and GraphDB Enterprise Edition, while with GraphDB 10 is just a single download. We decided to do this because it's much easier to just install one piece of software, regardless of the license that you want to use. And if in the future you want to, say, upgrade from GraphDB Standard to GraphDB Enterprise, you don't have to install things again. So it just makes deployment much easier. And I'm just going to start some GraphDBs. Then another thing we decided to do differently is in GraphDB 9, we used to have a dedicated repository type for each of the GraphDB editions. So when you had to create a repository, you had to choose between a GraphDB free repository, a GraphDB standard repository, and in the case of GraphDB Enterprise, there were 2 different types, a worker and a master repository. While in GraphDB 10, there is just a single GraphDB repository, which is again, the reason for this change was that makes things much easier in case you want to upgrade, or if for some reason you also want to downgrade, that's also very easy to do when you have a single distribution and a single repository type. Okay. Then a sort of not very visible changes, we changed how the remote locations in GraphDB are handled in the workbench. So the remote locations are a way to attach to another GraphDB instance that's running on another machine and connect to it. And up to GraphDB 9, when a remote location was attached, it could be activated in order to be used. And unless it's activated, it was just something that sits there and didn't do much. So let's just attach here to another location. So the GraphDB that I'm running right now is GraphDB1 and then the other GraphDB I attached is GraphDB2 at example.com. And in GraphDB 10, all of the locations are always active at the same time. The local location, namely this GraphDB, is the one that is visible through the RDF4J API. And also if you use the RDF4J client, which uses that API, while the remote locations are visible only in the workbench and usable only in the workbench. So let's create two repositories. So in the redesigned repository creation dialog, now there is a field that allows you to specify the location, which by default is the local location, which means this GraphDB. So I just created the repository in the local location, and I can very easily create a repository in the other location. And now let's say we want to use the local repository. We just make the repository active. We can go to the Sparkle editor and add some data. I'm going to use one of the sample queries to do that. Here we just insert two triples that describe some information about an IRI example, book one. So I'm just going to insert this data, and if we do a quick select, we get the data back. And now here from the repository selection drop down in the top right corner, we can change the repository that we want to use. As you can see, we have the local repository, repo one that we are connected to, and we have the remote one, repo two. And now I've just changed to the remote repository, and as you can see, now this repository is shown here in a slightly different way. It's the repository ID at and the shortened host name of the machine where this repository is hosted. And we can try to insert some data here as well by changing the IRI of the book to book two, just to be sure that we are not writing to the same repository as before. And we can run the same select query to check if the data is there. So just a summary of the remote locations. Their main use is to, if you want to quickly connect to another GraphDB and perform some work there through the workbench, and only through the workbench, because if you want to connect to that GraphDB, the remote one, in this case GraphDB2, through the RDF4J API, you can just use the actual URL of that location instead of going through this GraphDB. And the other main use of remote locations is to make cluster management in the workbench easier, which I'm going to show you later. So let's go back now to repo one, and we are moving on to the changes in the GraphDB connectors that we did in GraphDB 10. So the main difference in the connectors in GraphDB 10 is the filtering. In GraphDB 9 and earlier, the entity filtering in the connectors used to have a single filter for the entire connector definition, and this filter historically developed as a combination of a filter that filters out individual fields, the values of individual fields, as well as entire documents. And if you wanted to use it for something more advanced, it became very confusing on how to write a filter. So we decided to split this entity filter into several individual filters that each apply at a different level, and also create some new filters. So now in GraphDB 10, instead of this single filter, you have 4 different kinds of filters. There is the top level value filter, which is applied very early in the process when only the document ID is known, so that you can get rid of documents even before collecting values. Then there is the top level document filter, which is applied after all of the fields values have been collected, and it can be used to skip entire documents based on the particular values of fields they contain. There is the per field value filter, which is applied whenever an individual field's value has been collected, so that you can restrict the values in this particular field. And finally, there is a nested document filter, which is similar to the top-level document filter, but applied whenever a nested document has been collected. And just to remind you, nested documents are a feature that is present only in the Elasticsearch connector and the Kafka connector. And then another very nice feature we introduced in GraphDB 10 is two-variable filtering, which allows you to compare the value of a field to the value of another field. In GraphDB 9, it was possible to compare a field's value only to a constant. So, for example, you could say, I want the salary to be bigger than, say, 50,000. But in GraphDB 10, you can say that I want the value of this field to be bigger than the value of that other field. And now we're going to look at an example that illustrates using the new filters as well as two-variable filtering to achieve something that wasn't possible before with the old version. So here we have a piece of data that describes employees, the roles these employees had at particular time, as well as internal investigations performed against a given employee on a particular date. And just for the sake of example, the only employee defined here is me with 3 different roles. And as you can see, the roles started at a particular time, ended at a particular time. So for example, me as a team lead started in 2015 and ended in 2021. And at some time later than 2015, namely 2017, I got an additional role as a software architect, which also ended in 2021. And finally, my current role is the product owner of GraphDB, started last year. And here we have 2 different events, internal investigation, that were done on particular dates. And what we want to achieve here is create a connector that indexes all investigations, the employee against the investigation was performed, and the role this particular employee had at the time of the investigation. So we need to match the date of the investigation against the dates of the roles. And if we go back to GraphDB, and we import this data, so this is the same file that you just saw. So we import this data, and then we need the connector definition. And the connector definition just says that we want to index documents of type internal investigation, and defines a couple of basic fields such as the employee against which the investigation was performed, and the roles this particular employee had. And the roles is a nested field, which in itself has its own fields, the position that was held at the particular role, the date when the role was created, and the date when the role was deleted. And of course, the investigation date of the event, which is outside the nested document. And all the magic happens here with this filter. This is the a filter of the nested document kind, where we compare the value of the role, the date when the role was created, with the investigation date, as well as the date when the role was deleted, again with the investigation date. So we want to index only roles that started before the investigation date and ended after the investigation date, or they are still active. So when the row is still active, there will be no row deleted. That's why we have this or condition here. And so we can create this connector. Just for the sake of brevity, we are going to ask Elasticsearch directly to give us a list of all the documents. And here we get 2 documents that correspond to the 2 events, namely investigations, event 1 and event 2. And if we have a quick look back at the data, here are the 2 events, the 2 internal investigations. And if we look carefully at the roles that were attached to each event, we see that event 1, which happened in 2018, performed against this employee, and it lists all the roles that this employee had at this particular date, namely the team lead, which was still active at that time, and the software architect position as well. And then event 2, which was performed on the 12th of May 2022, contains only the other role, which became active in 2021 when the 2 other roles were no longer active. So to summarize, the new filters in the connectors enable much more powerful use cases that weren't possible at all before. So it takes time to learn how to use those features. And the new filters are incompatible with existing connectors. So you have to, if you use filters in your connectors, you have to rewrite the filters. But we have some guidelines in the documentation on how to do that. So there is a migration step here that will tell you what the basic steps are to do this migration. And finally, let's move on to the new GraphDB cluster, which is probably the most exciting feature of GraphDB 10. Let me just do some, stop the GraphDBs that I used for this and start my other GraphDBs because I'm going to need them for the cluster. So the previous cluster was defined on an architecture that was developed in-house, and it had a master node and one master node and several worker nodes. And the master node always remained the master node. It didn't contain a copy of the data. It just sent requests to one of the workers to perform the actual work. This architecture didn't prove to be very robust because if your master node fails for some reason, you need another master node. That's why we decided to redesign the cluster using a new architecture that is based on the Raft consensus algorithm. And to show you what the Raft algorithm does, I actually like this small demo that you can play in a browser. So in a Raft cluster, you have many nodes, and in this particular case, there are 5 of them. So each of the nodes can have a particular role at any given moment. And the main roles are the follower and the leader. So the follower is the one that listens to commands from the leader and replace transactions and all that, while the leader is the one that initiates all the transactions and controls how things happen and so on. And at any particular time in a working cluster, there is exactly one leader and the rest of the nodes are followers. So when such a leader starts, all of the nodes are followers. So whenever there is no leader, they will detect this situation, and one or more of them will become a candidate. So just like in human relations, when there is a lack of governments, people want to elect some government. So one or more of them become candidates. And I'm going to start this visualization now. Note that it's 1,000 times slower than what actually happens in a Raft cluster. So blue means they are followers, green means they are candidates, and when they become a leader, it becomes reddish orange. So now when I start this, one of them will become a candidate, and actually 2 of them became candidates, and one of them won the election and became the leader. So as you can see now, the communication happens through the leader. So the leader sends heartbeat to the rest of the nodes to check what's going on. And that's how the Raft consensus algorithm works. Every decision in this cluster is based on majority voting. So for example, whenever a write operation occurs on the leader, the majority of the nodes have to agree about the outcome in order to deem this transaction as successful. And it's exactly the same with the election. So now let's move on to how we do this with GraphDB. So the easiest way to set up a cluster is through the workbench. But before you can set up a cluster, there is something that you need to do in order to make all the GraphDBs that you want to connect together compatible. Just like in the old cluster, all of the nodes have to have the same setting for this one. It's the shared token secret. The secret is used to sign the authentication tokens when security is enabled in GraphDB, as well as to verify the cluster communication. So this is the only setting that you need to predefine in the config file. It needs to be the same on all of the nodes that you want to connect to a cluster. And the rest of the settings I have here are just a way to enable me to have 5 different addresses on the same machine. So if your machine is set up correctly, namely it has a host name that's resolvable from the other machines that are in the cluster to the right IP address, you don't have to do these. But in case your network configuration is not exactly the way it should be, these settings can help you make things right. So to set up a cluster, you can go to Setup Cluster. This screen has changed considerably since the old cluster. It starts with this big circle that says no cluster group configured. So in order to create a cluster, you click on it. And to create a cluster, you need a minimum of 2 nodes. But it's important to note that in order to have a functional cluster, you need at least 3 of them. And if you want to increase the number, it's always good to keep the number odd. So 3, 5, 7. That's a good number of nodes to have in the cluster. Why the odd number? Because when you have majority voting, it's much easier to achieve consensus when the number is odd, because consensus is achieved when half of the number of nodes plus 1 agree about something. And in order to create the cluster, you have to attach the other GraphDBs as remote locations. I'm just going to activate this signature authentication type here now, even though it's not needed because security isn't enabled on this GraphDB nor on the other GraphDBs, but I'm going to show you something later. That's why I need to do this here now. And here, this dialog is the same as the one that we saw earlier when we attached the remote location. So when you attach a remote location to this interface, you essentially attach it in the workbench just like using the other dialog. So I've attached GraphDB 2 and 3. Now I'm attaching GraphDB 4 and 5. And now I just have to choose the locations that I want to use to create the cluster. As you can see, the current GraphDB is always active. It has to be a part of the cluster, and then these are the other GraphDBs that I've added. There is also this advanced options tab here that has some timeout and other configuration options, but for the time being, you can just simply go with the default values because they are same, so we don't have to change them. And when you click OK, the cluster will be created. All of the nodes will become followers in the beginning. As you can see, these here are all followers, and now one of them has initiated the election, or more than one of them. As you saw, this one became green for a brief time, and then it became orange. So now we have a fully functioning cluster. And just to explain you, quick note, this interface is supposed to have a legend here, which is still not ready because this is not the final version. But to give you a quick explanation, the node that is orange with the eye icon is the leader. The blue nodes with the label icon are the followers. And for the brief time this node was a candidate, it was green and the icon was a check mark. And the lines from the leader to the followers indicate that a green solid line indicates that the leader is in sync with the followers. So now this is a fully functioning cluster. Which of the nodes becomes the leader when you create a cluster is not something that can be predetermined, so it's pretty much random. And in this case, I was connected to GraphDB1 in the workbench, and GraphDB1 became the leader. So now if I want to write to this cluster, I have to use GraphDB1 because that's the leader. But if any of the other nodes became the leader, I would have to connect to its workbench in order to do some write operations in the cluster. For the final version, it will be possible to do write operations from any of the nodes, but for the time being, it's only on the leader. And now let's try to import some data. Of course, we have to create a repository. So as you can see, all of the locations that I added when I created the cluster are listed here. And I can create a repository. And the repository, as you see, was created here on this GraphDB as well as on the other GraphDBs because they are all connected together in a cluster. Unlike the previous cluster in GraphDB 9, where the cluster was defined at the repository level, in GraphDB 10, the cluster is defined at the GraphDB installation level. So whenever you create a repository, it's automatically in the cluster. So now we can import some data in this repository. So this is just two popular ontologies that contain food and wine information. And if we do a quick select here, we get some data that's in the cluster. We can pretty much use this GraphDB as if it was a single node. So it's in no way different than a single node when it comes to using the GraphDB. We have a repository. Transactions work exactly the same way as they do in a single node, which wasn't the case in previous versions. And since we are running out of time, besides, I'm just going to let you know that besides this interface, there is a REST API to create the cluster as well, so you don't have to always use the interface. So there is a REST API to create the cluster, to delete the cluster, to check the cluster status. So you can automate this very easily using curl, for example. And what happens when a leader fails? Well, in the Raft consensus protocol, whenever a leader fails, one of the other nodes will initiate election and become a leader. So this architecture is very reliable. It handles failures very nicely. So the cluster should be always operational as long as not most of your nodes fail. And for those of you who started late, the session is recorded. You can watch it later. Since I'm running out of time, I won't be able to answer all of the questions that you asked. So I will look at the questions later and maybe try to answer them by email, or we could create a blog post. So thank you everyone for your time. Now I'm handing off to the next session, where my colleague Peyo is going to show you how you can leverage GraphDB and some ontologies in the financial services sector. Thank you again, and goodbye from me.